Okay, here we are finishing up level 10, or unit 10 as I say. Our unit on conics. The first three problems in our review ask us to write an equation. So they give us some information, and I kind of started ahead just plotting the points. We have a center at 0, 0, a vertex at 0, -4, and a focus at 0, 3. Now I can label all these other parts, but let's see what we can get just from this information. I know that my center is at 0, 0, so because this is an ellipse, I'm not going to have any transformations or any values subtracted from x or y. So I have x squared plus, for the ellipse, plus y squared. And my a squared and b squared values are going to go down below x and y. Because this is a tall ellipse, and I know that because my foci are on the major axis, so my major axis is going this way, my a value is going to go under y squared, and my b squared value is going to go under x squared. So I can find those. I know that A is going to be the distance from the center to the vertice, and that's 1, 2, 3, 4 units. My B value I'm not sure of at this point, but I do know my C value is my center to the foci. That distance here is 3 units. To find my B squared value, or my B value, I know that b squared equals a squared minus c squared. And if I put those values in here, a squared is 16, c squared is 9. So 16 minus 9 is 7. So I know b squared is 7. And my b value is going to be the square root of 7. So now, just from this information, I know my b squared value is 7, so that's what I'm going to put here. And my a squared value is 16. And that's all I really need to do for this one. It doesn't ask me to graph, so I just need to write the equation. Number 2 is a parabola. My focus is at -1 up 4.5, halfway between 4 and 5. And my vertex is -1 up 3. I know that the focus has to be inside of the parabola, so it's going to open up. And just like in a quadratic equation, we have an x squared. So I'm going to go off the basic formula, x squared equals 4ay. Now my center, or my vertex, is not at the origin. So my vertex is going to be the point over, up, I have it all right here, over to -1 up 3. So these numbers need to be our h and k values. So I'm going to have x minus h, which is -1, so that's x plus 1 squared, equals 4a times y minus 3. Now this 4a here, I know my a value is the distance, and don't get these confused with the a here. My a value is the distance from the center to the foci. The distance from the center of the vertex to the foci, this distance right here is 1.5. So if I multiply 4 times 1.5, I'm going to get 6. So in standard form, this is going to be x plus 1 squared equals 4 times 1.5 is 6 times y minus 3. And that's my equation of this parabola. And then we have a hyperbola. And I have vertices at -3, 3, 5, 3, and 7, 3. So this is my transverse axes right here. So I know that in my hyperbola, the x term is going to go first in the equation because it's parallel to the x-axis. So if I find my center is going to be at 1, 3. So my center is 1, 3. So now I can kind of put this into my equation. So I'm going to have the x term first. So I have x minus, this is my h and k value, x minus 1 squared over something, minus y minus 3 squared over something equals 1. So I need to find these somethings, and that comes from my a, b, and c value. So my a value is the distance from the center to the foci, or center to the vertice. So this is going to be 1, 2, 3, 4 units. So if a is 4, a squared is going to go under the x, so that's going to be 16. My c value here is the distance from the center to the foci. So I'm going from 1 all the way down to 7. So that distance is 6. To find my b value, I need a squared plus b squared equals c squared. So a squared is 16 plus b squared equals c squared is 36. So b squared here has to be 20. And that's the number I need to put under the y-coordinate. So this is the equation of the hyperbola in standard form. Okay, so for these, they didn't ask us to graph, so we just graphed the pertinent information. In number 4, here we are being asked to graph and to label depending on what the equation is. So this is an ellipse because it's x squared plus y squared in standard form, and my center is at the origin. So this is an ellipse. My center is 0, 0. So here's my center. This is, my big number is 25, so a squared is 25, so a is going to be 5. So 5 up and down on the y-axis, 1, 2, 3, 4, 5. So this is for my vertices, over 0, up 5, 0, 5. And then I'm going to have 1 in the other direction. This is 0, -5. Then I'm going to have my b value. B squared is 16, so b is 4. So along the x-axis, I'm going to go 4 units. So this is 4, 0 and -4, 0. So there's my vertices. And my foci will come from the equation b squared equals a squared minus c squared. Okay, you can kind of just draw this in. Vertices, this is my center, and my b squared value is 16. That equals 25 minus c squared. And 25 minus 9 is 16, so c squared is 9. Whoa, sorry about that. And my c value is 3. So from my center, I'm going to go up 3 units. So for my foci, I'm going to have over 0 up 3 and over 0 down 3. Foci, foci. On number 5, here I have a parabola, and I know that because y is squared but x is not. So if x were squared, that would be a parabola like we've seen with quadratics. But since the y is squared, we're going to look at opening to the side. So if I think of the general form, y squared equals 4ax. Okay, I don't have any transformations here, so my center is 0, 0. Or in a parabola, it's just the vertex. So we have a vertex at 0, 0. And I know that this 4a has to equal 12. So if 4a is 12, a is 3. So that means I have a focus 3 units away from the center, and it's a positive 3, so I'm going to go in the positive direction. Vertex, foci, and it's going to open this way. And I also, if I label that, my focus point is at 3, 0. And I'm also going to have my directrix. And this is going to be also a units from the vertex, which is in the other direction. So here is my directrix. And this is the vertical line, x equals -3. Okay, so that's all I need for my parabola: vertex, focus, and directrix. I got all 3 parts. On number 6, this one is an ellipse. The center is not at the origin. The center is at my h and k values, which is -1, +2. So I'm going to have an ellipse here. And my center is at -1, +2. -1, +2, here's my center. I know that 9 is my bigger number, so my major axis is going to be horizontal. And my a squared value is 9, so a is 3. So horizontally, I'm going to go 3 units, 1, 2, 3. So this is over 2, up 2. And 3 units in the other direction would be over to -4, up 2. So there's vertices. My b value, this is b squared, so my b value is the square root of 8. So from C, I'm going to go up and down the square root of 8, which is approximately, it's a little less than 3, so let's say 2.8-ish. 1, 2.8, just below there, 1, 2.8, just below here. So these are vertices, and I can kind of make my ellipse here. Now, if I label these vertices, my x coordinate is always going to be -1. And it's my y coordinates that are changing. I start at, my y coordinate is 2. And to get to this vertice, I'm going to go up the square root of 8 and down the square root of 8 to get down here. So I start at 2, and I'm going to go up and down the square root of 8. Okay, so that's labeling my vertical vertices. And now I need my foci. My foci comes from the equation b squared equals a squared minus c squared. B squared is 8. A squared is 9. So it's 9 minus 1 that equals 8. So c squared equals 1, and so does c. So I'm going to put 1 unit away from the center are going to be my focus points. And if I label these, this is going to be -2, 2 up 2. And this one is going to be over 0 up 2. Okay, so that's all we need on that one. Ooh, this next one, we've got some big numbers and it's not in standard form yet. So before I determine if it's a ellipse or a hyperbola, I'm going to put it in standard form. I know it's not a parabola because my x is squared and so is my y. Okay? If it's a hyperbola, I'm sorry, if it's a parabola, just one of them is squared. So I'm going to group my terms. I'm going to put 25x squared next to plus 200x. And then I'm going to put 16y squared, and that's positive 16, y squared minus 160y equals, and I'm going to send this number to the other side, so that would be minus 400. So for each of these, I'm going to complete the square, and that's going to tell us where the shift is going to occur for the center. But before I complete the square with the x's, I'm going to factor out a 25. And that would give me x squared plus, and it's 25 times 8x. That gives me 200x. And in this perfect square position, I'm going to take half of 8, which is 4, square it, I get 16. But really, in this side, I'm adding 16 times 25. And that would be plus 400. So I'm going to add that to the other side. For my y's, I'm going to factor out a 16. And I'm going to have y squared minus 10y plus some number. That's the perfect square. Half of negative 10 is negative 5. Negative 5 squared is 25. So 25 goes here, but I'm really adding 16 times 25, which again is 400. And if I factor this, I'm going to have 25 times x plus 4, quantity squared, plus 16 times y minus 5, quantity squared, equals 400. I need a 1 here, so I'm going to divide by 400 on all parts. And we're going to clean this up here a little bit. So when I cancel these, 25 goes into 400 16 times. So I'm going to have 16 on the bottom. So let's write this up here nice and neat. So I'm going to have x plus 4. This is quantity squared over 16 plus, I'm going to have y minus 5 squared over, and 16 goes into 425 times, and that's going to equal 1. So this is the equation. This is an ellipse. And my center is at negative 4, positive 5. All right, so let's get that center, negative 4, positive 5, right here. Now I need my vertices. So my A value, it's going to be a tall ellipse because my A value is going to be 5, the number underneath the y, because it's bigger than x. So A is 5, B is going to be 4, and we'll find C in just a minute. So from C, I'm going to go up 5. So this is going to be the point negative 4 up 10. And down 5 would be negative 4 up 0. And then along the x-axis, I'm going to go 4 units. 1, 2, 3, 4. So this is the point over 0 up 5. And 1, 2, 3, 4 this way. This is the point negative 8 up 5. So these are all my vertices. Make a nice little ellipse here. And to find my foci, I'm going to use the formula b squared equals a squared minus c squared. A squared is 25. I'm trying to find c squared. I know my b squared is 16. So it's 25 minus 9 that gives me 16. So c squared is 9 and c is 3. So from my center, I'm going to go up 3 units. So this is the point negative 4 up 5 plus 3 is 8. And then I'm going to go down 3 units, and this is negative 4, 2. And just label everything. And there we have our ellipse. The hard part on this one was really just getting it into standard form with all those big numbers and having to factor to complete the square. All right, number 8, I'm guessing is going to be a hyperbola. And I'm thinking that because I have a y squared that's positive and an x squared that's negative. So I'm going to have a y squared minus x squared. Okay, so just kind of organizing here. But let's group the y terms. So I'll have y squared minus 4y plus some number to complete the square. And then I'm going to have minus 4x squared. And then my x term is plus 32x. And then I'm going to add 64 to the other side. Well, I'm going to complete the square. And I'm going to add 64 to the other side. So completing the square with the y's, I'm going to have y. Actually, this is half of the middle term is negative 2. If I square that, I get 4. So I'm adding 4 to this side, so I'm going to add 4 over here. So this is going to be y minus 2 quantity squared. And before I factor this side or complete the square on this side, I want to factor out a negative 4. So I want to say I have minus 4, and then what I would multiply negative 4 by is x squared. That gives me a positive coefficient of x squared here to complete the square. And then negative 4 times negative 8, x, negative 4 times negative 8 is positive 32x plus some number. So just double checking, negative 4x squared, negative times negative is positive 32. All right, so half of negative 8 is negative 4. Negative 4 squared is 16. And 16 times negative 4 is negative 64. So I'm really adding negative 64 here. So this becomes negative 4 times x minus 4 quantity squared. And I'll clean this up here in a second. So what I have here, my 64s will cancel. So I have that equaling 4. So I want to divide every part by 4. So I have y minus 2 squared. I'm going to write this nice and neat down here. So y minus 2 quantity squared over 4. I gotta divide by 4. Here the 4's will cancel. So I have minus x minus 4 squared over 1. And that equals 1. All right, so this is a hyperbola. And the center of this hyperbola, remember our h and k values, h has to come from the number with x in the parentheses. So my x coordinate is 4 and my y coordinate is 2. All right, so I have 4, 2 is my center. So here's my center. Now, what I know for this, my transverse axis is going to be up and down because it's with y. So this is my transverse axis right here. So all of my important pieces, my vertices and my foci, are going to go on this axis. Okay, so my a value is 2. My b value, b squared is 1, my b value is 1. So if I go up 2 and down 2, I'm going to have my vertices. So this is over 4, up 4, and this is over 4, up 0. I also need to put my foci on this part right here. So my foci comes from a squared plus b squared equals c squared. My a squared value is 4. 2 squared is 4. 1 squared is 1. So c squared is 5, and c is the square root of 5. So the square root of 5 is a little bit more than 2. So from my center, I'm going to go over up 2. Here's my foci, very close to my vertice. Okay. If I label these points, my foci, where do I want to put those? Let's put them down here. My foci are going to be with an x coordinate of 4. And then my y coordinate starts at 2, and then I add the square root of 5, and I subtract the square root of 5. So I start at 2, plus and minus square root of 5. All right, to finish this up, my b value is 1, and I just need to put those points in here so I can draw my box to get my diagonal asymptotes. And if I look at the slopes of these, the slope of this one is going uphill, so this is positive, up 2 over 1. And this one is going downhill, so I go down 2 over 1. So my slopes are 2 and negative 2. Here's my equation. And the last thing I need to do is draw in the branches. So I go from the vertice towards the asymptotes. All right. Woo, one more. This one I know is going to be a parabola because x is squared, y is not. All right, but I do have a parabola that doesn't have a vertex at the origin. So I need to group my terms. So x squared minus 4x equals, and I'm going to complete the square, so I'm going to leave that space, equals 4, and I'm going to send the 4y to the other side. So that's negative 4y plus 16. Oh, minus 16, because I'm sending this to the other side as well. So here, to complete the square, half of 4 is negative 2. Negative 2 squared is 4. So I add 4 here, I add 4 here. I'm going to factor. So this is x minus 2, quantity squared. And on this side, I'm going to have negative 4 times, and then if I combine this, I'm going to have negative 16 plus 4 is negative 12. So this is minus 4y minus 12. And technically here I can factor out a negative 4. So this would be negative 4 times y plus 3. Negative 4 times positive 3 is negative 12. So in this parabola, I know because x is squared, it's going to open up like it were a quadratic. It's going to open up or down. And my center is going to be my h and k values, which is 2 and negative 3. And my negative 4 that's right here, if I think of the equation x squared equals 4ay, so I have my y part right here, so negative 4 equals this 4a here. So 4a is negative 4, a is going to be negative 1. So this tells me that my a is going to be in the negative direction. So here's my center at 2, negative 3. My a value is going to be down 1 from my center. So this is my focus point. This is my center or my vertex. And I'm also going to have a directrix that's up here. And this directrix is the line y equals negative 2. And just drawing my parabola there, the foci has to be on the interior of this. And I think that's all that we needed here. Just to kind of clean this up again, my equation is x minus 2 squared equals negative 4 times y plus 3. And this is my parabola. All right, that should do it for this review.